Hello everyone, my name is Jeff Rhoads. I'm a professor in the School of Mechanical Engineering here at Purdue University. And today I'll be talking about some of our recent work at developing sensing systems for the on-site detection of traumatic brain injury. You don't have to look far in the news today to see that concussions and the study of concussions are everywhere. Perhaps most evident these days in the context of professional football, where we see rather serious injuries occurring on the football field with significant hits leading to player injury, traumatic brain injury, and even worse in some situations as we talk about things like CTE. But I think one of the things that's important for us to recognize is that for every football player that we read about in the news, there's many thousand more high school, junior high, elementary school athletes, our own children for example, that are suffering from these types of injuries, as well as things like soldiers in the field. And this problem extends not only to these populations, but folks that are in automobile accidents, workplace injuries, etc. Now the interesting fact is despite these occurrences of traumatic brain injury that occur each and every day around the globe, our methods for diagnosing traumatic brain injury are kind of on two extremes. On the simplistic end, we do things like field diagnostic testing or cognitive testing, the simple how many fingers am I holding up, who's the president, what's your last and first name. Rather crude techniques that allow us some diagnostic ability, but in some sense is introducing a lot of errors and under-detection. On the other extreme, we have complex machines like MRIs that can do functional analysis of the brain and how it's performing. But the challenge is there's really not a lot of solutions in between these two extremes, and that's where we seek to fit in. Over the course of the last few years, me and my research team, consisting of Purdue faculty and students and graduate research assistants, have been working on sensing systems and sensing technologies that leverage resonant mass sensing, the ability to detect small quantities of material, with proprietary dispensing technologies that allow us to analyze small sample volumes for detection purposes. And one of the unique things about these sensors is that we can develop low-cost disposable sensors and pair that with reusable instrumentation for depositing the analyte and for doing other sorts of functional analysis to develop sensitive and scalable technologies that are useful at point-of-care type operations. This technology is both reliable and low cost, and as you'll see from the diagram here on the right, we've been able to show with a high statistical degree of success the ability to detect the protein biomarkers associated with traumatic brain injury. And we believe that this is a real breakthrough in our technology and ability to diagnose traumatic brain injury. The other thing that I should note here is that our technology is protein agnostic, and so we detect a lot of biomarkers for a lot of diseases and other conditions. And so if you're interested in learning more about this, we encourage you to reach out. We're certainly interested in partnering, and we'll take it from there. Thank you very much.